Hi and welcome to another episode, and what we've got here is nothing fancy. LED strip kit, and I bought 3 of these, which ended up being 4. I'll explain that in a little bit. But it's 5 meters of LEDs. It comes on a reel, obviously, and it's got a little controller and all the fun stuff. But let's have a look at what it says on the back, which I do find that strange that the flap is to open here, but you know. But on a shelf I suppose it would look good that way. So anyway, yes, the text on the back somewhere. I'll not read it all out to you, but basically it's blah 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 blah. It's SMD 5050 LED chips, IP65 waterproof coating, 24 key remote control. It has 3M adhesive backing for the mounting, something else I'll talk about in a bit, and basically it reckons it's really good. Now it does mention that it comes with a controller and all that fun stuff, which again I'll explain a little bit later. It reckons it'd be great for lighting rooms, gardens, bars, nightclubs, shop windows, one cabinet, because it's just a cabinet, just one cabinet, automobiles, so plenty of all those sort of things. Or any other type of application you wish to use. I don't recommend stick it in your bathtub or the washer or something like that, or trying to put it in your cooker. I wouldn't do that, but anyway. But then it mentions, unlike the LED strips that use 3528 SMDs to simulate colour, new generation of LED strip lights are made with 5050 SMS LEDs. Is it SMD or is it SMS? Come on, nothing fancy. Sort your text out. Anyway, blah 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 blah. It reckons you get eye-blistering 3,800 MCDs, and they last longer. As you can tell, I am not sponsored by these people. They can do if they want to, but they're not doing it right now. But anyway, LED strip lights last for 50,000 hours. So what's that in days, months, years, and whatever? A long time. They come with a protective waterproof sheathing to prevent any water drip or excessive heat damage. The strip also has an authentic 3M tape, specially designed to handle years of usage in stormy weather. You get 16 million colours. You can do like flashing and all that funny stuff, and of course, since it is RGB, as I say, 16 million colours, which I bet is more like 16.7 million colours, but you know, can be placed anywhere. Right, so there's basically all the fun stuff they say on the back. Now I want to say some stuff about what it actually says. The waterproof stuff is for the LEDs. It is not for the power supply unit. Do not get confused. It also, the other stuff is, the one thing that they mention is the 3M tape. The 3M tape on the back of it is pretty much useless. Because, and you'll see why in a moment, so we have the reel, we have the controller and some stuff. It comes with a power cable, in my case a UK one, and it comes with a cardboard box, which inside the cardboard box is in fact the power supply unit. So let's get rid of these cardboard boxes out of the way. Crash bang wallop. What we have is the power supply unit, and it is light, very light. I mean, you can just tell by how easily it's swinging around. Yeah, it's very light, but with modern technology, I understand it doesn't have to be a huge brick like it was on a Commodore 64 or something like that. But it does say on the back of here, indoor use only. It says it twice, in fact. So this must be indoors, but then you could run a wire outside, and then basically if anything goes wrong, you're hopefully not going to burn your shed down or whatever it is that you're trying to light up from outside. So I've been using one though for a few days, you can see over here, because what I've been doing is basically teaching myself on how to actually get this kit going the way that I would like it to be, because in this kit, you get 5 meters worth. So a bit of rustling. Again, let's get out of the way. Well, actually, it says on there runs between so and so and temperatures of storage temperatures fine between -40 and +80 degrees Celsius, and operating is fine for -25 and +60 Celsius. So, you know, it may well do something like make your windowsill look nice from outside in the garden or something like that, you know. But as I say, you'd want the power supply unit still to be indoors. So how you get that outdoors and still everything, that's your trouble. The part of the LED components cannot be fixed on any surface of sharp edges. Strips should not be coiled or crushed. What's that then? What is that, apart from coiling it? Very strange. Strip can be cut following the cutting lines. The strips must not exceed 5 meters when used in a DC series circuit. Well, there's a bit of a problem there. I need more than 5 meters worth, and they sell them in 10 meters. So I'm not too sure what to believe, because as many people who follow this channel know that I'm still very much a noob when it comes to electronics, and probably will always be a noob when it comes to electronics. But one thing I do recommend when you get one of these is test it. Now, it does have the pins already there, but you can also, if you wanted to, open up this little pack. Again, throw that out of the way. And we end up with the controller, which is Wi-Fi controllable, uses infrared with a fancy little remote control, which has the obvious on, but it also has flash, strobe, fade and smooth on the buttons there. What they all do, I'm not 100% sure, especially the smooth, but in general you can do a fair bit from here. Obviously there's not 16 million colours to control from here, so you have to use the app to do that. Let's get the remote control out of the way. This is a little card that makes sure you install Magic Home on your mobile device, and basically it goes off to a website and then you pick Android or iPhone. And then it's also got kind of like a document sheet that explains the basics to you of how to plug everything up. It doesn't tell you what to do for modifying it. It says for that you should contact the people that make your LEDs. It also mentions on how to search for it and everything like that, and I found it quite easy to get it going on my mobile phone. It wasn't really too difficult. I have an Android phone. It was easy enough to follow, and basically the same code is in 2 places. The other fun thing though that you can do with this is get your smart device to work with it. So if you've got an Alexa Echo Dot type thing, or you've got one of the Google's Play things, you can control stuff there. You have to install their app and link it all up. I'm sure you probably figured all that out before with other devices, but yeah, you have to install their third-party app, sign in through that, link it to your account, and then you can shout at your Alexa to turn it on and off, change colors, all the fun stuff like that. It's not as controllable as the app is, and I'll let you play around with the app. It's got some very strange and wonderful things that you might want to use, and other things you just think, okay, that's fun, but yeah, okay, I'm not really going to use it. As in, it has one thing with the app of where you can point it at your TV and it'll try to take an average, and then you can move different ones, if you have more than one, to different sides of the screen, and it'll try to average it out in that general area and then make the LEDs glow that particular way of doing it. So if you had a smartphone pointed at your TV constantly, you could do that fun stuff of where the LEDs around the outside, I'm pointing at the TV as if you can see, LEDs all around the outside and glowing a certain patch. But of course, if you walk in front of it, you're going to make everything go completely wrong. So it's a fun idea, but a bit useless. But it also has other things of, it'll do your music and, you know, disco type lights, or you can even just talk to it and it'll bounce around to it. So that's some of the fun stuff. I might show that at the end of the video, I might not, I'll decide later. But what I want to point out is testing these. Now I learnt the hard way. Oh, sorry, before I get on with doing that, double-sided sticky pad, so you can stick this someplace afterwards. And it also gives you another set of white pins, which it seems to recommend that you use on this one. Why they give you two sets, I don't know, because it says any further than 5 meters in series, and then you have this. How would you daisy chain up another lot? But anyway, you can just plug it in like that. Now I've already got one plugged in, obviously just the infrared receiver there. I've got some power now. Yeah, I'm plugging it in while it's hot, but what you can do is test it like this. Now I did that, and as you can see, every single LED is lit up. And then one thing you might have also noticed for the ones that have used LEDs before, these are a little bit more expensive than other ones, not just because it's got the whole Wi-Fi and Alexa smart control sort of stuff. It's because there's actually 300 LEDs on this 5 meter run instead of just 150, which seems to be quite a standard for the cheaper lot of LEDs that you can buy. Not maybe in quality, but you know, because there is less LEDs, you're getting charged less. Makes sense. But I learned the hard way because I actually started working on these, and it turned out that all the way into the very center there was some LEDs that were a little bit flaky, because as it says not to do, don't crush it, they had been over crushed in the center and the circuit board was broken. And I've just spotted on this one, hopefully I'm not going to suffer the same problem again. So let's take them all out. I'll jump cut this because it'll be boring for you to watch all of this. Okay, so I've unraveled it all. Make sure that there's a little connection on. There is a little arrow on here, and you need to make sure that it lines up with the arrow that is on the device. So we've linked it up, and there we go. The whole strip is nicely lit up. But be careful though, because initially what I did was test them while they were still on the reel, and everything did light up in one pack. But then when I unraveled it all, basically there was a section around here somewhere that just didn't want to work. I don't know why, but I had to bend it so that there was a connection and it would work. I'm sure there was probably some way of doing a bodge wire and everything like that, because there is some solder points up on top, but that would then mean that I'm losing the IP65. So I contacted the seller of these, and they basically instantly said sorry and sent out a new pack. So I will be putting a link to that particular seller in the description below. As I said before, I'm not sponsored by them, but I will put a link to them because things do happen. You can't always control the 100% of quality of what's happening, especially if they've tested a strip on a reel and it appears to be working. I think what might have happened is that as it had been put on that reel, it had been done a bit too tight near the center, and that had crushed the PCB. So don't just test them while they're on the reel and say, yep, they're okay, and then work on them in 5 days' time. Take them off the reel instantly, all of them, and test them. Because if there is a problem, at least it gives the company, no matter which company, but it gives them a chance to say sorry and send you out a new whole reel of everything, a whole new box with it, not just the LEDs, but everything. So let's go back to playing around with these now. Now, as you can see, I've got some angled corners and I've got some extensions. Now, these extensions ones I'll talk about later, but basically it's just some straight through pins. Well, let's talk about the corner ones, because it's basically the same difference as what you have to do for those ones, but of course you need to be able to make sure you're going around the correct way. Now, let's say we're coming to the end of our reel. Let's just pretend we are. But we want a right angle off to the right. Now that's all good and fine because the copper that's on here, we've got positive, we've got green, we've got red, we've got blue. And surprise, surprise, that's what these markings on here are as well. I'll just zoom on in so you can see a little bit easier. Not too far because we don't want to keep going in and out of focus too much. As you can see, there's some writing there and it does say 12 volts, green, blue. Sorry, green, red and blue. And it matches up to the markings that are on here. Now the problem is though, if you want to go the other way, the markings on here still say blue, green, red and positive, but then they don't match up correctly to what's here on this particular bit of copper, because obviously that's not changing. So what you need to do is just forget about the markings that are on the corners, because they're of no real help. What you need to do is remember, basically think about it of like a scalemetric. And if you don't know what a scalemetric is, go look it up, because you should. But it's a bit like that, they're all the same, different lanes in a highway or motorway, whatever you want to call it. So if you're on the left lane, on that one and that one and that one, if you're on the left lane, you need to stay on that left lane when you're going around. So if you've come up here and it's a positive lane, it's the plus 12 line, you need to make sure that is on the left hand side and it's still on the left hand side as you're coming off, not coming on, coming off this little corner strip. And then the same goes for the colours. So basically though, if you line up the 12 volts, it's always going to be lined up, so not to worry about that. But you have to make sure it always is. So this way around, positive is on the left lane, and as you're following it round, it's still in the left lane. And really that's the easiest way of remembering how to do it. But just make sure that you line it up. You're not going to blow anything up. It's just if you do stick on the LEDs at the other end the wrong way around, they'll not light up. And you'll think something's drastically wrong. And you'll mess around and mess around and mess around. Now you'll also come to see why it's very important, because part of the problem, let's zoom in a little bit more, and I'm sorry if you can hear my neighbours banging around and screaming kids and everything like that. What the problem is that, let's try to get some focus on here. Why does this thing never focus properly? There we go. There we go. The problem is that this particular strip of LEDs, and this has happened on every strip of LEDs that I've had, that there's a dimple there, no dimple, no dimple, dimple, no dimple, 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 dimple. And I'm sure there's some people smirking at themselves right now, but that is a bit of a problem. There should be a dimple at the top and the bottom of every bit of this copper. Because when you stick on one of these connectors, as you can see, it sort of presses, well, it's aimed downwards. And the whole idea is that it rests against one of those dimples because that's slightly raised. And if one of the dimples isn't there, it's not really, it slides in, but is unlikely to make a decent connection. So what I've been doing is snipping these in half for where I've been snipping these in half for where I need a connection, lifting up the IP65, cutting a bit off because the IP65 won't fit in these connectors anyway, and then actually soldering the 4 points at both ends. So there's actually 8 connections, and then I've been putting them on, and sometimes I get a really good connection, but sometimes I actually have to solder onwards as well. And of course, when you've soldered 4 points, it's a pain to have to desolder all those points when you come to realize you've stuck it on the wrong way. Now, you can sort of swap that round, but that in itself can cause problems because it seems that the connections inside there are sometimes only just doing it, and sometimes you have to solder them up as well. But let me show you how I've been solving the problem about soldering it. Now, the one thing I wanted to point out too as well before I get to that is the 3M tape that they boast about of being on the reel. There's your problem. What's that going to stick to? Because it's stuck to it there because whoever was going around with it and doing this as they were fitting it, they didn't do it in a straight line. So now you have no surface. It's too tight. There's no surface. So I highly recommend you also buy yourself your own reel, very, very big reel, depending on how many of these things you've bought, to cover the distance of it, because you might have to fix a better connection of the tape because it's just not very good the way that they've done this. Quite often on the tape. I mean, that's just a waste of time now. Oh, that's come away and the stickiness is dried. So get yourself some your own 3M, and I highly recommend you get the 3M tape, which is actually is red, not grey, because the grey stuff seems to be the cheap stuff. But as I say, let's start cutting this so I can show you how to do what I've been doing. Okay, so I've unraveled a bit of where I want to start the cable. Also, what I want to do is measure out how far I want to go with it. So let's start off with here. Now obviously what I did at first was measure twice and exactly how far I wanted it to go for the edges of my shelves. So since I've done it once and I've tested that it fits, I'm sure that I'm okay for just lining it up, but you want to make sure that you're always cutting in the correct spot. So here we go, I want to cut here, and for that I need some scissors. And of course, as soon as I've done that, I'm going to lost my space now. Oh dear. It's been a long week, let's put it that way. Alright, so definitely there, right. Keep my finger on that this time. And I want to snip sort of where there is dimples up and down. Gives you a guideline of where the center is. It would have been nice if they had drawn some black lines so that you knew in the middle, but you know, you get the idea. And then snip straight across. Don't curve as you're doing it. Make sure you get a nice a nice line straight across as best you can anyway. Let's put that out of the way. Now I've chopped this end off, put that to the side, and what we need to do is bring up the IP65. Now I've found that a nice way to do it is to use the wrong end of a Stanley knife or a craft knife, whatever you want to call these things. Basically that's the sharp side. I want to use this side. Still wouldn't want to jab it in my finger, but you know, stuff. And by the way, that has nothing to do with what I was doing. It's a silly mistake. It's something else. Now basically using the blunt side of the blade, carve just above where the copper is. Maybe I should zoom in again. That should do. As you can see, I've gone above the copper but below the IP65, and slowly but surely putting some pressure, keeping my fingers well out of the way because you know you don't want to jab yourself in the finger. It's never a fun thing to do. And then lift up just a little bit, and then push down just a little bit, and then that should be enough. Always put the blade away, you don't want to carve your finger up. Get your scissors again, push the scissors into the gap that you just created. Don't chop your fingers off, and just snip all the way across. That leaves you with a nicely exposed area for the copper. Put the rubbish to one side and we find the end of the other end of what we want to make a connection to. I'm not going to bore you and show you every single connection. I'm just going to show you the two types of connection that I've been doing. But we have this, and then we need a Stanley knife again, and this is where you can maybe start up a little bit of a factory of figure out the different lengths that you need, snip all the different distances, and then come back and do this kind of work, and then do the soldering bit, which we'll be doing in a moment. So you're doing all the same thing again and again and again, which can get boring, especially when you're doing 15 meters of it. Now with this one, you'll notice that there's 2 solder points behind the copper. So I forgot to mention that on the first one. The first one, go far as back as you can next to the first LED you bump into. But when it's 2 lots of solder, go up to a point of where you're sort of halfway through where the solder points would be, or are rather, because that seems to give enough distance of it's possible to push it inside the connectors. So pull back a little bit, snip. There we go, it all bounces all over the place. Put that in the rubbish there. So we have 2 connections that we need to solder up now. Get the soldering iron turned on, pull out some solder. Got plenty of it here. Because this copper is so smaller points and we're doing it again and again and again, we don't really need to bother around with using flux, especially since this particular solder has flux in it anyway. But because it's very thin copper, so be very careful. You don't want to actually pull these copper bits off, you know, you don't want to be doing that. I've been using this particular solder iron around 350 degrees Celsius. Seems hot enough to actually be doing the job, but not hot enough to burn everything. Is actually with the solder. Let's get everything lined up. Oh, and I said before, when you finish with the blade, put the blade away. See, we're not all experts. You know, do what I say, not what I do. No, yeah, that's it. Right, do the copper with some heat, and then put the solder on, and you want a nice little bulbous part of the solder on there. So sort of clean the copper with the heat of the iron at first, and then melt some solder in place. You don't need loads and loads and loads, but you do need, you know, it looks good. It's not just completely flat. And then there we go. That's what that one done. And while we're here, I might also do the next one. So it's quick and easy to do. It's not a high skill level of using a soldering iron. You're basically just cleaning off the copper so that it's easy to get the solder on there, get a bit on. I also find when doing it that push the solder towards the LED. That way, when you remove it, it seems to leave a nice little curve and everything like that for where you actually need it. Because if you do it by dragging away, you end up with a flat bit, a load of solder on the iron, and it doesn't leave the bit that you need. You know, it doesn't leave it where it's a little bit bulbous, as I said. And you get to a point of where it's not exactly one movement, but close enough. That's that. And then what we need to do is actually make the corner unit, corner piece actually fit. So we have the starting point of the LED, and let's just pretend we do want it to go off to the right. So at first you think, oh, it's going. It doesn't. What you need to do is raise these points, and I find using this screwdriver, which is a 1.2 times 30mm screwdriver, so 1.2 is just the right size. You can see it's a very, very small point. It's just enough to sort of wangle underneath the area of where you would normally just slide it in dead easy, to bend it up just a bit, basically the thickness of the tip itself, nothing more than that. You don't need to carry on pushing, just push flat against the plastic at the back and that will raise the pins high enough, at least with this tool. And we'll do it with the other one as well. So as we said, we're going to make it go off to the right. Line that up. There is a couple of little tabs on the side of the plastic. So that fits in there quite nicely now. But it doesn't necessarily mean you've got 100% of connection, but don't worry about that just yet. And then the same with the other one. Slide that in. As I say, sometimes it goes dead easy and other times it's a bit awkward. But you can see why I cut as far back as I did, because when this closes down, I need the IP65 to be out of the way. You'll also notice with the little flap that closes, you maybe can just see on camera, it has a couple of ridges that press down onto the pin area to make a decent connection. As you can see, this one has actually fallen straight back out again, which is fine because you want it to be easy to get it in there in the first place. And what we do now is mess around making sure that the pins are going into the unit properly. So as you can see, the far row of the LEDs hasn't lit up. Now, have I actually bothered to make sure the positive is on the outside? So yes, it's all should be going down like that. So is it making connections? Push down on the points. Oh, seem to have pushed that one back out again. See, I made a mistake there by pushing down too hard on that one. I am showing it like doing it like this because you're not really going to get an electric shock by doing this, and if the LEDs do get power from a different bit, they seem to have a bit of where it'll shine white, and basically as long as you don't leave it for too long, they should all survive. There we go, see, like there's a connection, but it's not so great. And this is what I was meaning. Stuff, so we get that in there. And this is where it becomes obvious that actually what you need is to solder some solder through those points. So unplug them again. And with that, you can just use a solder that you've already put there. And hopefully that makes a decent connection. So test again. And it hasn't, of course, just to be annoying. How annoying. And as you can see, messing around with a bit of solder to go across the top pins, across the top, helps actually give you a decent connection sometimes. So you can close that up, which can be difficult in itself. And I found getting a stupid sized pair of pliers, or whatever you've got, basically something that has a very big flat edge, not pointy. And yes, I'm doing this while it's all turned on, but it's an easiest way of making sure that you've got a good connection. By using that though, it means you're putting a lot of pressure down, it's a flat area. I'm not actually touching any of the solder points or the connections, and a little tab for the plastic is enough to hold it. So there's a corner one, and yes, it can be painful in the realms of having to mess around to do that, but it is still a very easy thing to do. Seriously, if you've not got high soldering skills, don't worry. You know, as long as you can draw a circle with a ballpoint pen, you can do enough soldering to do this. Seriously, it's that easy. In the realms of that, it's just annoying to have to do it, because if it had those little raised bits in the copper in the first place, we wouldn't have to be messing around doing this. Now, we have done a straight one, and of course, a corner one, but then I want it that there's LEDs going down the front of my shelf, and then I want LEDs going down the back, or the left hand side of the shelf, or whichever, you know. But the point is that I want LEDs to go across, down that side, down the front, and down that side. Well, since I've shown you how to do a corner one, I'll not show you how to do the other corner, because it's just the same again and again and again. But as I say, you have to make sure that the plus 12 volts is always following down the same path. So if it happens to be on the inside of the corner, make sure that it's following around. Or if it's on the outside, make sure it's on the outside. But just make sure it's doing it, because then you know that if you're not lining up the next line of LEDs, it's down to there isn't a good connection, versus you've actually got your LED strip the wrong way round, which, believe me, is easily done. But as I say, I'll now make up the next corner. So we have another one of these down this side, and then I'll show you how to make it so that you can go to a whole new shelf. So I've finished off the last corner of that shelf. So just for the fun of it, let's pretend we're going from the lowest shelf up, well, not the lowest shelf, but the one above that, to the shelf above that. Just being pedantic with myself. But basically we're moving up a shelf, and I need to be able to get from here to here. So how do I do that? Now obviously these extender connectors work well, but there's nothing to connect between there and the one that's on this one. To do that, we need to use some wire, and what I purchased was this, because this was actually the cheapest thing to buy at the time, to make sure I had more than enough for everything that I needed to use it for, and it'll come in handy for other things as well, I'm sure. But it's 22 AWG 4-pin RGB extension wire. It's built for the job. 12 volts is what we're using for these LEDs, and obviously all the way up to 24 volts, but you know, only 12. 100 foot of it, or 30.5 millimeters, 30.5 meters of it. It came with 10 extenders, but the kit that I bought that had these L-shaped things in had 10 of them as well, so I've been using those ones. And then LED light strips, extended wire for 50/50 or 3528 type LEDs, and it's OFC wire provides maximum conductivity. I'm not too sure what OFC stands for. Could someone tell me what that stands for? Say down below in the comments, because it's always fun learning new stuff. But as you can see, a daft amount of it. I really don't need this amount, but as it was the cheapest that was on there at the time. So what I've found is, one, measure twice. Always measure twice. That's a good lesson to learn in life. So what I'm going to do is go measure that for the particular shelf, and then I'll show you how I get the connectors on. Might not be the best way, but it's the way that I've been doing it. So I've cut myself a length using some snips. These come in handy for other reasons, and the other reason is if you happen to come across a part of the LEDs of where it's pre-soldered, because what they do is use a meter at a time, and for whatever joint you're doing, you might land across a solder joint, and the easiest way to cut through is just to use the snips. At the same time, it kind of comes in handy because the solder's already there if you are doing a joint. So first things first though, what we need to do is now get this strip of wire onto a joint. And the easiest thing is to get yourself something like this. Cuts the ends off of wires. Now, the easiest way I've found just to get just enough of wire is, obviously you've got this rest here to go up against, but actually that's a bit too far. So pull back to about there, start to grip, fold it down this edge here, because otherwise it'll just slip. I actually have it on the tightest setting it has, but this is a bit too thin for this. If you pull it back like this though and hold it there, it actually stops it trying to drag it all the way through, and then in one clean movement you've chopped off all the ends. Now you're probably thinking, why haven't I bought one of these before? I don't know. Why didn't you buy one of them before? Because they do come in handy for lots and lots of times of where you're trying to get the end bit off. So of course we need to do that at the other end as well. So as I say, put it up close to the little plasticky bit. Bring it back just ever so slightly. Maybe I'll do it the other way around, you remember to see. With the blue wire there, there we go. Get close to there, start to grip so it's not right next to the plastic. It can be close, but just not so close. Roughly there's enough. Bend it down the edge and pull off. And sometimes it doesn't always get the tightest, the one that's furthest to the back. So you just do it again. This time lining up where the snips are on this side to where you cut before, because obviously there's no point cutting again and again and again. But try again, and there we go. This time it has actually got all 4 points off. So put that to the side. They're not very expensive, those tools, but well worth getting one into your toolkit. But this is where we now have fun trying to put this on here. Now be sure that you keep with the wiring standard, because you may remember with, where's the other end of this? Here we go. You may remember that it was white on this particular one, whereas this one is black for the plus 12 volts. So just remember that you need to wire that up the correct way around. And what I've been doing is making it that the black wire is on the inside of where it closes. So if I'm doing it from one side, it's like that, and if I'm doing it from the other side, it's like that. But again, you have to always make sure that whichever side you did it is the same at the other end, because you don't want to put a twist in it, because that'll make things confusing for yourself. Now I also have this contraption, some helping hands. And one thing's first you want to make sure is that the wire, the bits aren't actually touching each other, and the easiest way to do that is to split just a little bit, not too far. They do need to be slightly apart anyway when they're connecting into the connector. Try to twist it a little bit if you can. I'll try to centralize what I'm doing in the video a bit more, sorry. Putting a twist in it just makes it easier to tin the ends, and by tinning the ends, I'm sure plenty of people already know. For those that don't, all it means is to stick some solder on the end, because putting solder on now will be easier than trying to put solder on later. So again, we me just put some solder on. So heat the wire from the underside and then put some solder on and do it as relatively quickly as you can. Move backwards and forwards, and there we go. It's now tinned. You may have to come across the top as well to get some on. And putting a bit of a twist in, you see, helps it stop from fraying so much when you're trying to do this. You don't need huge globules, yeah. You don't need that much on there really, but you do need some. And again, if you know how to use a paintbrush, you know how to use a soldering iron. Not a great detail, but you know, you can draw lines. But then we need to get it on here, and again, what we need to do is just move the pins just a little bit, and then put it in the contraption. Try to line it all up, and then you solder those 2 points together, and I'll do that off screen because I hide everything that I'm doing anyway. Actually, I sort of discovered myself like an even easier way of doing it. Basically, push the two areas together and then come at it this way and press down on the different solder points, and with the fact that you've already tinned it, makes it easier. So I'll get on with doing the other end as well. As you can see, I've made my extension cable, which won't be in a curl like this when I put it up, but that means I can get on with doing the next left, right, as it were, of doing the shelving. So a few more of these extension cables to be made, some more corny bits to be done, but apart from that, it's a really good way of doing this, I think. Of course, the huge reel that you need to be pulling out and making sure works, and everything, so the ones that you're affecting, I do recommend that you cut out all your short bits if you're doing it for this kind of shelving, and all your long bits. Basically get all your measurements done first and cut to what you exactly need, so that when it comes to building it, it's cut, and do all your solder bits first and then make the connections themselves, because it's just easier to get through your head of where you've cut, you've soldered, and then you've done your extension cables and so on. So do it like that, I recommend, or do it bit by bit if you want, you know, if it helps you not get bored. The next bit I'll show you now though is all this stuck up, but one thing I do want to mention though is, as I've said already, that I think I have anyway, the 3M tape that's on the back of here isn't very good, and you should get your own. Now actually getting your own makes it appears it will be easier to put up when finished. Just let me unplug this for a moment because I don't want it getting too bright and everything and annoying. But basically what I've bought is some 9mm 3M tape, because this is 10mm or 1 whole centimeter. Now I've bought some 10mm stuff because that's what there was currently I could get the next day sort of thing, when I came to realize that this stuff that's on here isn't very sticky at all, as I think I've already shown you that in some cases it's not even stuck to the back of the LED strip, because they've put it on, they've sort of done this with it, and when they've put a bend in, that of course means it's a straight line for the 3M tape, but there's a bulge for the LEDs. But it also means though, by putting up your own tape first, you can actually put it on the area of where you want to stick the LEDs up first, before sticking LEDs up, because trying to stick this up all by yourself with all the weight of it time you finished is quite a difficult job, and a lot of fiddling and everything like that. And so instead of shouting at inanimate objects, put the double-sided sticky tape on the surface you want to stick to first, and then slowly but surely run this down onto it. Now obviously this is got 3M tape on, So what I'm going to do is take off the backing of this so that there's sticky on the underside of the shelf, and then there's going to be sticky on here as well, and it should make a very good bond time it's finished. So go on then, get on with making all your LEDs, and I expect you to be finished time I show mine, which of course is in the next transition, so get on it. Well, after using the double-sided sticky tape that's already on the back of the LEDs, and then buying even more 3M double-sided sticky tape, it turns out the people that sell LEDs, at least some good people that do, they actually bother to tell you that that stuff isn't good enough when you're hanging it upside down. You need to use some double-sided sticky foam instead. Now they recommend a particular type to buy directly from them, this other LED seller, but I've searched and find something that seems to be quite similar. So 36 yards, nearly 33 meters worth of it, far too much. But it looks like this instead, and hopefully this is going to be good enough to make everything stick upside down. Why on earth the LED makers just don't sell it with decent enough glue on the back of the double-sided sticky tape in the first place to solve all problems? Not a clue. But anyway, let's try this one out instead and see if it all works, because it was a real pain sticking all the LEDs up, at least one whole stand of shelves all the way up, just for it all to fall down just as I went to go, hey, look what I've done, and it all started drooping and falling off. So try this one. Alexa, retro lights blue.
Okay.
Alexa, retro lights green.
Okay.
Alexa, retro lights red. Alexa, retro lights purple.
Okay.
As you can see from the last bit, I could control the LEDs with Alexa, and they've grouped in the main light of the room, which is also RGB, so it all matches up quite nicely. But this is the main app that you get on your phone or your tablet. As you can see, I've got shelves 1, 2 and 3. They're out of sequence because of the alphabet. Let's have a look at the group that I've put them all into. So as you can see, I can pick and choose whatever I want, or the little information of from 0 to 255. So there we go, I can pick whatever I want. You can also set up your own presets. We go to function and we can make it do funny stuff like cyan, gradual change, red green, crossfade, 7 color strobe flash, so you can be in a dodgy nightclub, I don't know. Customs, you can create your own. Mic, with this one it uses the phone's mic, and with the different frequencies it'll make the lights dance around through the preset colors that you have, and you can change the sensitivity of it. You can also minimize this app to play music from any source such as Pandora or Spotify, and your LED device will automatically synchronize and change the color to the music. So that's what it's really for, so you can use a third-party music device, a player or whatever, and make it do that way, but it does do it to your voice obviously. You can also play music and do the same sort of thing, but from MP3s on the device that you're using. A cinema one, basically you can set some mood lighting. You can decide if you want it on the floor or on the ceiling, and around the TV if you've got one just over there sort of thing. And then we can change for the camera as well, and it can sort of average out. So in this case it's using the mouse mat, and you can see the color just there averaging itself out to different ones. So if I on the dragon here it's mostly grey or black, but if I go up to here it's mostly orange. You can see that it's mostly orange now. The other thing that you can do is set an alarm so the lights come on at a certain time, or the LEDs I suppose we should call them, but of course if you turn it off, the LEDs off of the wall, it's not going to work. Really cliche really, isn't it? I've had fun setting this up. It's taken a lot longer than it should have done, and when I say I've had fun, I mean that in a sarcastic sense. It's been a lot more bother than it should have been. The the little copper bits on the LED strips should have been a lot better. The little corner strips, I've had to take them off and actually solder the little points on there as well to get a good connection. Yeah, it really shouldn't be that difficult with a decent connection with them. It just really shouldn't be. So even though that these were double density in the realms of 300 LEDs, the weather side of things have now been ruined, of course, because I've had to cut in to get to those points. That's my choice, not the company's, but if you want to move around in corners, you're going to have to do that. It'd be great if there was some kind of corner unit that was also waterproof. But apart from that, it's up now and it looks really good. As always, happy gaming.